Mostly what makes questions complicated is geometry. So if you know all the geometry, if you know all the coordinates that you need, you solve for this, then everything will be very simple because you will always be using the equation or the same concept actually. Let's start here with this question and you'll see that it's always the same concept. The range A, okay, so there is a range here. Um, there is a range A and there is another range B. So the range A is used to hold the pipe in a stationary position. So this range is used to hold the pipe. Now what is saying here? One wrench is applying, is making the rotation, okay, and the other wrench is trying to stop that pipe from rotating. So in both cases, you are applying a moment. One moment is needed to make the rotation, and the other moment is needed to stop that rotation. Is it okay? Clear what I'm saying? Now, it's let's start. So this question is divided into two parts. The first part says determine the magnitude of force FB. So this force, in order to drop a torque, which they mean a moment of 50 Newton meters about the y-axis. So this is our specified axis. Now we know because it says about the y-axis, we know that this is our specified axis. All right. Now, what is the required magnitude of force FA before force Fa? Now it says determine the magnitude of force Fb in order to develop a torque of 50 newtons meter above the y-axis. So يعني before we go through anything, just let's draw a line on the specified axis and let's draw a line on the line of action of the force. Okay, sorry. I haven't drawn this well. So a line in here. Clear? Now we know that we need now a line which is, oh sorry, an arrow which depicts a position vector from the line, the specified axis to the line of action. So let's choose an arrow. Where do you suggest? Let's you suggest any point?
لازم يكون على الواي اكسس.
Because it's it's asking you about the y-axis. We are
اوكي.
specified.
دكتور الخط المرسوم لازم يتملي.
So maybe here you choose the points where يعني you have known coordinates. So the along the y-axis, let's choose firstly a starting point that is known. So we could either take 0 or we could take this one. I think this is better because if we take 0, then
يس.
we'll end up having, yeah. So we'll take this one. And now where do we end? We end, of course, at this point. We have not.
هذا اكسل.
Yeah. So this will be our position vector. Now you know that you need to solve for three things. You need you need a unit vector for the specified axis. In this case, it's already it's obvious, straightforward. It's just 0, 1, 0 because it's at the y-axis. So this one is u.
0 و0.
This is 1j. 1j. That's we know the y-axis. Now we need to express our force in Cartesian format, and we need to find the position vector. So guys, when you get a question, put the map for yourself. What do you need to do to solve? That's what I'm doing now. Maybe before putting the map, you could write the equation. M about the y-axis will equal to u, okay, our unit vector about the specified axis. Okay. Um, so I'm writing, I'm already written it here. Now let's start with R. R, we said it starts from here. We call this point C and we call this B. Now, the coordinates of C is easy. It's just 0.5 millimeters at the y-axis and 0 at the x-axis and 0 at the z-axis. But the coordinates of B is not known. Now you need to solve for the coordinates of B. So we know that this is a triangle, and so this is a line that would represent the x-axis. You see it's parallel to this one. So if you know that this is 30, so this line will be sine 30. Okay?
300.
0.3 sine 30. And you know that
Minus.
yeah, the y-axis is still minus. Okay. And because this line is actually lying at it's just 0.5, it doesn't take any further angle at the y-axis. And now with the in terms of the z-axis, it's the same triangle but take
Cosine.
But solve for these sines and cosines to make it simpler, and that's it. So you know now the coordinates of B and the coordinates of C. Now you could get, because you know C and B, you could get our CB. Okay, so we know RCB, and now we're done with RCB. Now what's remaining?
Unit vector.
F. We need F. So FB. We need to express it in Cartesian format. Now, there is one thing that you need to know. And when you have a force and you want to express it in Cartesian format, you have two ways. Okay, you have two ways to express it in Cartesian format. Either you take its coordinates, you know its x and y, but that's it. You take its x coordinates and you write it as your I and your y coordinate as your j, and that's it. Or maybe as z axis as your k. So either you take its coordinates, or if you cannot get its coordinates as simply, you could use the way that we just mentioned, that you take a unit vector and you multiply the force by the unit vector. But in this case, because you think about it, could we take a unit vector? I mean for FB, could we take a unit vector? Like for example,
أي واحدة دكتور.
we want to express FB as a Cartesian format. So could we take so we know we could do one thing. We could multiply the force by a unit vector. But my question is, could you take a unit vector here? Is it easy to solve it this way? The answer is no.
No.
The answer is no. Why?
Yes.
Because if you want to solve for a unit vector, you need to have at least two coordinates. Okay, joined together through the line that you're interested in. But in this case, it's impossible to get for example this coordinate. It's impossible. So directly when you have an issue like this, you know that you will not solve it using a unit vector, but rather you will solve it using the components way. Okay, so in this case we know the angle, and that's what you need to know to do. Your concern now is to know the angle from the x-axis or from the y or z-axis or whatever, to know what will be the coordinates of FB. Now, okay. Now, since this is okay, I'll get back. Since this is a 90 degrees, yeah, this is a 90 degrees. This is a 30, so this obviously will be 60. This angle. Now we are approaching this. So from the position vector, Okay. So from this vector or from this line to the x-axis is 60. Now it's saying that this whole angle is 120. So this is again a 60. So now we know how we know the angle from the x-axis to the force. Let's draw it again. So I'm drawing it again here to make just this picture is clearer than this one. So FB is directed at 60 degrees from the x-axis. So now we could get the x and z component. The x component. Let me draw this. Maybe. Okay, so we want this component here, okay, and this component. واضح? So this is f bx and this is f bz. This is sine 60 and this is cosine 60, and in both cases you multiply by the magnitude of fb. And that's solved for the force and makes explicit in Cartesian format. And now you're sorted. You have R, you have the force, you have the U. So you apply cross product and solve for the unknown FB. Okay, because we know the moment now, and we could solve for the FB using cross product, and this gives you the answer. Clear, Shabab?
Yes, clear.
Okay, so you see, it's it might be complicated, maybe time consuming, but it's just you need to solve for the little bits of geometry and trigonometry to get to the answer. Now, the second part of the question is saying that we know that, okay, we knew now just now by solving for this part that we need a force of 192 newtons to FB needs to be 192 newtons to create a moment of 50 newton meter. Now we need FA also to create a moment of 50 newton meter. Okay, and you see the question here, it's asking what is the required magnitude of force FA in order to counteract this moment, the 50 newton meters moment. So you again do the same thing. It's simple. It's just repeating the same thing again. Take the coordinate A. Take the coordinate. Sorry, this should be A. I'm mistakenly wrong. B here. This should be A. And take the coordinate D so as to solve for the position vector, and you've solved it. Now we need to express FA in Cartesian format. So we again go through the same procedure. We want to know where it's directed from a known axis, which is either X or Z. So now you know that this is 90. So this will be 60. And because this is 60, this is 30. Now, this is 135. So this will be 105.
كيف طلعت الزوايا يا دكتور؟
Okay, أنا بعيد هنا.
ايوه.
This is 60. This is 90. Okay, صح?
Good.
This is 60. And this is again 90. So this is 30. And this is 135, right?
Yes.
So from the z-axis, this angle is 105.
105. Yes.
Okay, let's draw it now to make it in a neat way. So we're talking about 105 to here. So what will be the angle from the x-axis to FA?
X-axis to FA.
15. Okay, so 15. Now we're sorted. Since we know this angle, now we could solve for the components of FA, which is cosine and sine, صح? Times FA. We go through again the same procedure, which is now simple and you already know it. Cross product, and then you solve for the unknown, and this will be your final answer.